So in this lesson, we're going to talk about some bigger, more complex particles called hadrons. If I just recap, remember you had fermions, which were matter particles, and those were leptons and quarks. Hadrons are made up of a combination of quarks. So let's start with baryons. Baryons have a baryon number of 1 because in the world of experimental science, baryons came first. So what do you need to know about baryons? Baryons are made up of 3 quarks, any 3 quarks, and they have a baryon number of 1. And we also have antibaryons, which are made up of the corresponding antiquark. And protons and neutrons are probably the most famous kind of baryon. Now, if we have a look here, we have a proton. A proton is made up of 2 up and 1 down quark. But if we take the antiproton is made up of 2 anti-up and 1 anti-down quark. So this is a much larger list of baryons, and I'm going to use some of them as a way of illustrating how the properties of the baryon, like its baryon number, its charge, and its strangeness, depends on the individual properties of this quark structure. All baryons are made up of 3 quarks. If we have a look, we can see that the quarks have a specific charge and a specific baryon number. All quarks have a baryon number of 1/3. So the baryons themselves, because they have 3 quarks, have a baryon number of 1, and that's the case with all of them. Depending on the combinations, the strangeness and the charge will be different. Here we can see a neutron has an up, down, down. And you can see here the quark has a charge of up 2/3, down -1/3. So you can see why the overall charge on a neutron is 0. A proton has an overall charge of +1. If we look at the quark structure, up, up, down, and we see its individual charge structure here, you can see why the overall charge is +1. Strangeness is always 0 unless there happens to be a strange quark. Thanks. The strangeness of a strange quark is -1. And so these particles all have -1. Mesons are the second type of hadron. Mesons are made up always of 1 quark and an antiquark. So this K+ meson is made up of an up and an anti-strange. Now, the baryon number is always 0. Why? Because quarks have a baryon number of 1/3 and antiquarks have a baryon number of -1/3. So the outcome is always a 0. The charge depends on the charge of each individual quark. An up has a charge of 2/3 and an antiquark has a charge of +1/3. This is strange, so it's -1/3. So an anti-strange would have +1/3, and that adds up to 1+. Each meson correlates to a different combination of quark-antiquark. Note that the strangeness of these particles is a 1 because we are dealing with an anti-strange particle. Remember, the strangeness of a strange particle is -1 normally, but the antiparticle would be 1. I hope this all makes sense. So this is the crazy world of hadrons. Now, if we have a look at the big picture again, you should be fairly familiar now with this entire structure. You've got your fermions. Fermions are divided into two groups, leptons and quarks. Quarks then make hadrons, which can either be baryons or they could be mesons. On the other hand, you've got bosons. We'll talk about bosons next.